All right. Hello, everyone, and welcome back to the ASP.NET Core Community Stand-Up, where we discuss the latest updates and developments for web development with .NET. I'm Daniel Roth. I'm the Principal Product Manager for ASP.NET Core on the .NET team. And today I'm here with a very special guest. We have James Newton-King, Principal Software Engineer on the .NET Aspire team here to speak with us. Hello, James. Welcome.
Hello, Dan. I'm excited to talk about Aspire, the dashboard, and Blazor.
Fantastic. Yeah. So today the topic of discussion is the how the .NET Aspire team today uses ASP.NET Core and Blazor to build their product, to build the Aspire developer dashboard, which enables all sorts of fantastic features for your development experience, like getting access to real-time tracking and key aspects of your app, like your logs, your traces, and environment configurations. Pretty cool feature. But first, before we get into that, James, we should learn a little bit about who you are. Like, tell us, a little bit about yourself. How did you get started with .NET and end up working on .NET Aspire?
Well, I joined Microsoft about 7 years ago. I've been on the .NET and ASP.NET Core team since then. Worked on shipping the first version of SignalR for .NET Core endpoint routing. That was a fun project. Spent a couple of years working on gRPC for .NET. I've also been quite involved with Kestrel, working on HTTP2 and HTTP3, and doing a bunch of telemetry work in the ASP.NET Core area, and the last couple of years Aspire. I sort of got pulled in to work on sort of one small piece of the dashboard. David Fowler said, work on this little bit thing, it'll be great. And I started working on it. So to be in and out, like a small little adventure, and like a couple of years later, I'm still working on Aspire. But that's because I've been quite excited about the possibilities of Aspire. Before Microsoft, I was sort of a consultant for about 10 years, working on just building apps for real customers. And people may know me for working on Newtonsoft.json.
A few
So
people may
I'll
know
take
you.
credit. You're welcome, and also I'm sorry.
A few people may know you from that, James. I think is that still the top downloaded NuGet package on the NuGet.org. Yeah,
Yeah,
it's
I think
pretty amazing.
it's 6 billion downloads last I looked.
Lots of code running through that library. When you first built that JSON serialization library, did you ever think that it would become like what it is today, the most popular .NET library that's ever shipped on NuGet.org?
100%.
That was the plan.
Go,
Yeah.
go big
First,
or go home.
parse some JSON,
Yeah,
then profit.
yeah.
Yeah, that's pretty fantastic. Well, we're thrilled to have you today, and thrilled to have you, of course, working on now on the .NET platform and on our latest tooling and development story for building web applications, cloud-based applications with .NET. So you work on .NET Aspire, and we've talked quite a bit about .NET Aspire already on the community stand-up, and these are folks that are follow along pretty closely with our latest development. Some of them may also watch the Aspire community stand-ups, which happen.
Mm-hmm.
I believe it's the fourth Tuesday of every month. So if you're not already tuning into those, I encourage you to do so. But for people that are still trying to wrap their heads around this .NET Aspire thing, how do you explain to someone what .NET Aspire is all about and who should really be using it?
So you have probably asked the most difficult question today first. What is .NET Aspire? So if you could share my screen, I've got the Aspire overview. I'll talk to this a bit, but really I think everyone explains Aspire a bit differently, and I think the reason developers sometimes have a problem understanding what Aspire is it doesn't solve like one particular feature within your app. It's not like Entity Framework, which you use to talk to your database. It's not like Newtonsoft.json, which you use to serialize JSON. It's not like Blazor, which you use to render HTML. Aspire kind of sits alongside your app, and it's focused on improving the developer experience. So back in the day, building apps, you might have your database, and you might have your web app front end, and you hit F5 to run your web forms app, and you're talking to your database, and that was your entire environment. Compare that with modern apps where you will have caches, you'll have message buses, you'll have cloud resources. Obviously, you're talking with a database. You might have your backend services, your front-end web app, a backend for front-end, a BFF sitting in between. How do you run all of those things at the same time? Like the traditional F5 debugging experience that developers really quite like no longer works. So Aspire is designed to sort of solve those problems that you have, and really any other problems that the Aspire team sort of see people having trouble with, we're trying to fix. So the first way it solves it is with dev time orchestration. So you define your application in a CSS file, like your entire solution, and that can include .NET projects, include containers, other kinds of resources. And then when you run your Aspire app, all of those things will be launched simultaneously. Kind of like Docker Compose, but going beyond Docker Compose. So not just containers, but also your .NET apps and other executables. So if I scroll down to this example of a Aspire app host file, here you can see in C# code, we're defining our apps. First, we've got our distributed app builder. We're adding a Redis cache. So this is a helper method for adding the Redis cache image to the Aspire app. We've got a reference to a front-end .NET project, and we're giving it a name. And then something like Docker Compose doesn't have is you can then have relationships between these resources. You can have your front-end project say, I reference the cache, and we support this thing called service discovery and connection string management. So Redis, you need a connection string to be able to talk to it. But what is the address of your Redis container? You might not know that until runtime, or you might hard code it. And if you hard code it, how do you have multiple instances of your app running at the same time? They start getting confused. But service discovery means that we can look and see what the address of our Redis cache is, and then we just automatically inject it into the front-end app as a configuration value, and then from your front-end app, it becomes very easy to talk to your back-end cache. So that's developer orchestration.
What I think is really cool about this is that, like, sort of your poor man's orchestration in days past might have been, well, I'll just set up like multiple startup projects in my solution to get like the backend API and the front end web app all running. But what I feel like is different about Aspire is that this app host is really modeling the whole app. Like you mentioned, that it represents relationships. It kind of knows what all the pieces of your app are, so it can do these things like add value, like service discovery, like let the API part of your solution know about the other API that it needs to call, or the front end be able to call that API and discover all those addresses and orchestrate all that. That's the I feel like that's the orchestration part, and that's my little conducting effort right there. Orchestrating.
Yeah, like it brings back that F5 experience, like F5 to run your entire solution. Like we've gone beyond simple projects. Now we're thinking about the entire solution and running it. And something I didn't mention is, like, when you run your Aspire app, it starts up all your .NET projects. Like here, we've just got one, but if you imagine you have multiple, it will build all of them at once. And when it runs them, it will attach the debugger to all these .NET projects. So yeah, like I've seen people like have to attach the debugger manually to multiple to like figure out debugging, but here Aspire will just do that for you.
Exactly.
Next thing it does is integrations. So we kind of already saw an example of an integration up here. When we added the Redis cache, we could have just said add container and then specified the Redis cache image. But by using this helper method and this Redis cache integration, we also get connection string management and connection string injection when we reference it. So that's an example of a basic integration. We have a whole bunch more. If we go to the integration page, like you can see down here over on the sidebar, we've got a whole bunch of different integrations for the most popular things out there: MongoDB, MySQL, Postgres, Redis. There's a whole bunch of Azure stuff, Entity Framework. In the community toolkit, there are even more. We have integrations for Dapper and running Go apps, Java, Node, Python, Olama, so you can run your AI container locally, and so on. And then there's more that other people have made, like AWS, I believe, has their own integrations. But integrations are kind of taking what could be quite complex to set up and making it very easy to use in a sort of fluent API. An example which I often think of is it's very easy to add Redis, but if you want to then set up like Redis Insights and Redis Commander to like view Redis data at development time, I've seen blog posts which have like pages and pages of docs saying how to get them talking to each other. With an integration, it's very easy to just say add Redis, then add Redis Commander and Redis Insights, and like they're just done in one line. And like all that complexity is hidden behind some helper methods.
And one really great service to use with an Aspire integration is the like if we want to use an AI service, like if you're trying to add AI functionality into your app and you're trying to figure out how do I wire up to that model in the cloud, like an Aspire integration can really simplify that quite a bit.
Mm-hmm. And then we've got some Aspire project templates. So getting started is quite simple. We've got tooling, so it's relatively easy to add like an existing app to Aspire. And part of that is like we have this idea of a service defaults project. So the service defaults are sort of defaults that we think are well suited to building modern, complex, distributed, cloud-ready apps. So we hook into your app's configuration, and we enable things like resiliency using Poly. We set up health checks. We set up service discovery, mentioned previously. We set up OpenTelemetry. And that's just a C# file that you can customize however you want. And also sitting under the tooling banner would probably be the Aspire dashboard, which we'll obviously talk more today about.
Today, yes.
So the dashboard is when you start your Aspire app, that will start up the dashboard automatically, and the dashboard lets you view information about your resources that you have, their state, and then console logs, telemetry, and more. So that's the value I think Aspire offers. Like, it isn't solving a problem, like a feature problem within your app. It's really a suite of tools and patterns that sort of sit alongside your app that make it easier to develop and run on your local machine.
Yeah, like and I know initially I thought, well, Aspire is really about like if you have multiple processes, like once your app graduates from just having one process and you have now n processes that you're trying to orchestrate and deal with, Aspire of course adds a bunch of functionality there for observability and wiring up all the cloud ready defaults for resiliency and health checks and all these types of things. But then I even found that even with a single project, like if I just have like a Blazor app and I want to be able to, really easily see my traces and metrics, or really easily see the logs and these types of things, it even adds value there. And so you can, if you haven't tried out Aspire, you can actually add it to your existing apps pretty easily using like a right-click add Aspire orchestration gesture in Visual Studio. That's available. And there's also, I think the Aspire team's holding a regular Friday live stream where they're taking more real world applications, like things that have quite a bit of code in them, and then adding Aspire to them. You can check those out on YouTube. I think they're called Aspire Fridays is the playlist on the .NET YouTube channel.
Yeah.
Okay. So
the final thing I'll mention about Aspire is you can sort of use it as much as you want to. You can dial up or down how close, like how many of its features you use. Like you could use the dashboard completely by itself. A dashboard can run as a standalone container. Like that's probably the most minimal way to use Aspire. You could use it just for dev time orchestration. I didn't talk about deployment, but it also supports deploying
Right.
to ACA. We've recently added deploying as Docker Compose or Kubernetes, but you can use it as much as you want. Like quite a lot of people just use it for dev time orchestration, and then they still keep their existing deployment pipeline, because like deployment's something which is quite custom to different developers. So yeah, that's a sort of final thing I'll add on Spire and using it.
It can be purely additive on top of your existing dev experience. Okay, yeah, that's great. So if you haven't tried out .NET Aspire, you can just go to like .NET/Aspire, and that'll bring you to the Aspire homepage on the .NET website, and you can check out the docs and get going there. But we kind of today wanted to peek under the hood a little bit and see like how does the Aspire team make all this magic happen? James, you mentioned the Aspire dashboard. I don't, some people may not have seen that before. Can you show us a little bit of what the dashboard does, and then maybe can we talk a bit about how does it work and how did you guys build it?
Yeah, so we are using Blazor. Blazor server, to be specific. I don't know if Blazor server is still the right terminology these days.
That works. That's definitely the right terminology.
Okay, so all the rendering is HTML rendering on the server. I think one question would be like, why did we choose Blazor to build the dashboard? And the obvious answer is where like Aspire folks are mostly the aspnetcore team. The obvious answer is like, we made an HTML framework. We're going to use it if we're going to build an HTML website. It'd be weird if we didn't. So that'd be like the obvious answer. But I think Aspire is actually a very good choice for what we're doing. The dashboard primarily runs locally. ACA does also host the Aspire dashboard, but like the primary use case is running locally on your machine or on your network. And you typically there's not a huge number of users of it. Like we don't need to scale up to millions of users as a public website. We're sort of like a more intranet kind of website. We have typically just one user, which is the person running the app on their local machine. And it's a very fast development experience. The thing I like about Blazor is compared to building a single page app with something like Angular or React, is I find with Angular or React, you tend to build, you're really building two apps. You're building your JavaScript front end, and that's one app. And then you're building your back end services that it will get data from, and that's a completely other app. While with Blazor and having HTML rendered on the server, you can access the data directly from your Blazor code. There's not that extra step of going via an HTTP web call to a backend to get data. It's a very fast and iterative experience. So for example, on the resources page, so this is sort of like the primary homepage that you land on. We can come along here and we're just accessing data directly from the dashboard client. We're not calling off to a web service and like doing that extra hop. So that's probably the thing I enjoy most about Blazor, is the very fast experience of development.
Should probably mention that people want to see the same code that you're looking at. This all the whole dashboard is in the Aspire repo, right? It's in the github.com/.net/Aspire, so you can also follow along with what James is showing here in the open source repo.
Yeah. So actually showing what it looks like. This is the resources page that I just mentioned. Here you can see a list of all the resources that are running in your app. So the previous example of a app host file that we looked at on the Aspire docs had two resources. It had a Redis cache, which I believe we have here. Basket cache is an example of a Redis container. And then we also have a whole bunch of other containers running, and also a bunch of .NET projects. And if we go and look at the source code, this is the test shop playground app in the Aspire repo. This is sort of our copy and paste of the eShop app, although a bit simplified. You can see eShop as an example of a like fully architected cloud native .NET app. Test Shop is sort of like a simplified version of it. And here you can see we're defining our distributed app. We're defining a whole bunch of containers. So here's that add Redis you saw earlier. We're setting up Redis Commander, Redis Insights. There's also a whole bunch of .NET projects. So we've got our order processor. I think this is like just a console app, which is talking to a message bus. So it's just pulling messages off a queue. And there's a front end here somewhere. I can't find it off the top of my head. But you can see all those resources are now being displayed in the dashboard. And you can see the state as they change. So for example, when I started this app, it also launched a whole bunch of containers, which you can see in Docker Compose. And if I stopped one of them, so for example, the Postgres container, you can see that's now immediately exited in the dashboard container. If I start it up, it will go back to a running state.
Now the dashboard runs independently of your app, right? Like it's not part of the application. It does launch when you F5 and Aspire app host project, but it's not like part of your code or part of the thing that's going to get deployed. So how does it get all this data? Like what's it doing to actually know about all your resources and then pull in all the telemetry data?
So the dashboard, when you launch your Aspire app, the dashboard actually launches as another resource. So it is its own executable. It isn't like part of any one app. In fact, you can see it down here in the list. You can see we've got an Aspire dashboard resource. You wouldn't usually see this in your own apps. We hide it by default, but just because we're doing some local development, we show it here. Yeah, so the dashboard, it runs as its own app. Obviously, it's got a Blazor component to it, so you can view it. I did actually one small bit of preparation for this community stand-up is I made a diagram of how these things hand together. So dashboard, technically, I guess the dashboard should be in this resources box, but you have the dashboard app. It talks to the app host. So when I ran the app host for that test shop, it launched in a console app, just like you would expect for a .NET, an aspnetcore app, although the output's a bit different. We talk about a distributed app starting. The port for the dashboard is printed here. So it's located on this location, and there's a link here. We have some basic authentication on it, and like just passing this token in the URL will automatically authenticate you. Although if Visual Studio is launching the dashboard, it passes this for you automatically and logs you in. So the app host launches. It will then launch our development control plane app in the background. The development control plane will then launch the dashboard. It will launch all the resources and containers you have. And then the way the dashboard gets data, it really depends what kind of data you're talking about. So the dashboard uses gRPC to talk to the app host to get information about the resources. So when I started and stopped that container, information from the app host is pushed to the dashboard. So this is a streaming call, which is established when the dashboard starts up. The app host pushes that down to the dashboard. And then the dashboard will just automatically show live updates of your resources as they change. So that's resource data. If you view the console logs also come from the app host. So the app host, the development control plane, it is able to collect the console logs from all the resources that it's running, and then the dashboard calls off to the app host to subscribe to them. So if we go back to our app and we look at the console page and we look at the front-end app, we can see some traditional aspnetcore console logs visible. So this is also coming from the app host. Telemetry is different. So telemetry is actually pushed into the dashboard by resources. So when your resources are configured to use service defaults, we configure the .NET OpenTelemetry library to export telemetry information over this format called OTLP.
Which
OTLP.
Not surprisingly stands for the Open Telemetry Protocol.
Yeah, basically, it's the Open Telemetry Protocol. And there's representations of that in gRPC or HTTP JSON, and that gets exported to the dashboard. So the dashboard is both a server for Blazor, so your local developers web browser, they view the dashboard, they're viewing that over HTTP, but you can also make requests to the dashboard to send a telemetry. So for example, I will go back to our app, and in the dashboard, we have links to interact with these resources. So we've got our front end. So let's click here to view the online store. And this is our basic test shop app. Here we can add a bunch of hoodies to our shopping cart and click to empty the shopping cart. The telemetry that was sent to the dashboard, so for example, structured logs, this was pushed via OpenTelemetry. So structured logs are a bit different from console logs. They look similar, but structured logs have a bunch of extra information. Like you can view the log level, you can view structured information. So for example, this is a message that the HTTP request ended, and you can view structured information out of it. So this milliseconds elapsed is its own field, the status code of 200 was its own field. Then we can write filters to query on this stuff individually if we wanted to. So we could say, show status code, which equals 200 only, for example.
Bless you.
Yeah, so this stuff is pushed to the dashboard, which is quite different from the other data. Questions so far?
There was one question about the security setup. You talked a little bit about auth beforehand, but Shannon wanted to know how the connection between the dashboard and the app host gets secured.
Right. So we have what we do is when the app host starts, we give it a key, and we also give that same key to the dashboard. So when the dashboard then calls get resources on the app host, the app host says, do you have the authentication key I expect? And if it does, then it allows the request. If it doesn't, then it doesn't. So we're able to coordinate this because we have Visual Studio tooling or VS Code tooling launched both of these things, and we just push that key in, and we give the key to both parties, and then it's just a basic check on is that key valid. But there is a lot of code for authentication across the dashboard. We have authentication in basically every single direction. If you're the dashboard talking to the app host, we have a key that needs to be checked. I believe we use that same key when the resources, they send OpenTelemetry. Again, because we're coordinating the launch of all these things, we push these keys into all the resources, and then that just gets sent as a header when the OpenTelemetry gets sent to the dashboard. We have a slightly different authentication scheme when the dashboard launches and you want to view it from the browser. You can see we have this token. If you launched the dashboard from a web browser which didn't set that token, so for example, let me bring up Edge and I navigate to this, I get given this login screen. So most people will probably not see this login screen because Visual Studio or VS Code, the tooling, when we launch our Aspire app, it will automatically navigate you to this address, which will automatically set the token for you. But if you launch a browser which didn't automatically get this token, so you would see this if you were browsing the dashboard in standalone mode, you would need to go to the console logs and you copy and paste this in, and you enter that, and you're able to log in.
Makes sense. And the app host process in Aspire, like is that app host process also just a dev time only process, or does it have any sort of runtime existence when you actually deploy the application?
The app host is only a dev time thing. So this is purely for local development time orchestration. When you deploy your app, you would deploy it with environment variables already set to like inject, like we talked about service discovery. When you do deployment, you would, I don't know, you would hard code those, or however you would set those values of the different addresses, you would set those up manually, or you would let the Aspire publish and deployment tooling do it for you automatically. But yeah, this is purely a dev time thing. Kind of the same way with the dashboard. Like the dashboard isn't deployed with your app unless you choose it to be deployed with your app. If you want to deploy it as a container alongside your app and then configure your app to automatically send OpenTelemetry to the dashboard, you can certainly do that, but it isn't done automatically for you. It's purely a dev time thing. One exception to that is ACA. So ACA, when you deploy your app to ACA, they automatically host an instance of the dashboard for you, and they manage that for you. And you can configure your apps to send telemetry to the ACA dashboard, which will look very similar to this. And yeah, you can view that same telemetry.
And you can get to that like in the Azure portal, like you can navigate, like when you deploy an Azure Container Apps thing, you can like get to the dashboard for your application there. So that's actually a example of this dashboard is being hosted in a like production runtime service. It's not just like a local development environment. I know Philip here was asking about the dashboard and the choice to make it a sort of a separate app running in its own process in the browser separately from the IDE. I'm kind of wondering, like, why do it that way? It looks like dev tooling, and I'm guessing part of the reason is because we wanted to enable these kinds of scenarios where you can have the dashboard running in a container alongside your app, have it be part of the production management experience as well.
I don't think we ever, like when we originally thought about the Aspire dashboard, I don't think we were thinking of getting it running in the cloud at that time. We chose not to integrate it into the IDE because we wanted to support both Visual Studio and VS Code at the same time, and the integration experience for building UI and those is like completely different. We'd have to build it twice. While using web tooling, we can just build it once and it just works. I think another reason is it's just faster to build a web app. Like I find using Blazor very productive building a local app like this, and I don't think we'd have the same velocity, the same ability to add features at the same speed if we were trying to integrate into a VS Code extension or a full Visual Studio extension that we would with building it separately.
No,
but I don't think.
Do you ever wish you like? Has there ever been any cases where you're like, man, maybe we should think about doing some stuff here in JavaScript instead of in Blazor? Has that ever come up?
No. So we are starting to do more Blazor JavaScript integration, but I think Blazor has worked pretty well for us.
I know I didn't pay him to say any of that. So.
Yeah, and I think it should be clear. I've actually never used Blazor like to build a real app before this, and the Blazor folks haven't been terribly involved. Like I think I've approached Steve Sanderson and Javier maybe twice, with questions about how to do stuff, and like I probably could have just as easily asked on Stack Overflow or on an issue in the aspnetcore repo about like what's the best way to do this. So I have not been an experienced Blazor developer. In fact, I haven't really done any real web development probably in 10 years. It's probably the last time I did proper web development was 2015, and like the web development ecosystem has come a long way. There certainly weren't all these different Java CSS selectors available back when I was last doing CSS and JavaScript as well. I don't think JavaScript had the ability to do classes back then. So yeah, Blazor's been new to me, and I've found it pretty good.
It's great to hear. It's been enabling. I also remember the first time I sat down in front of Steve Sanderson's initial Blazor prototype and was coding a web app in completely in C#. And I remember just this feeling of like freedom. It was like, oh, like I knew some JavaScript, but I wasn't a very well versed JavaScript developer, and I felt like this enabled me to use the skills and tools that I know to really be productive fast with building web applications. Mm-hmm. David did ask just to confirm that the dashboard can be deployed and used for telemetry like in a Kubernetes cluster, and I think you've answered that. The answer is yes. You could deploy it as a container instance and just pipe your telemetry to it.
Yeah, you will need to do it yourself. Like you will need to set up the Blazor container, because the dashboard container, because it is a standalone container as well. You will need to set that up as part of your Kubernetes deployment, and you will need to configure it yourself, which can be quite tricky. There's a lot of development options, configuration options for it, and yeah, then configure your apps to export it. But like one thing you can do is you can set up the OpenTelemetry collector. So that's a tool that OpenTelemetry offer. It's also available as a container. And you can think of it as like a container that you send OpenTelemetry to, and then it can fan it out in multiple directions. Kind of like something like Yarp, sort of like a proxy for OpenTelemetry. So you could configure OpenTelemetry collector, and you could send telemetry to the dashboard, but you could also send telemetry to something like Azure Monitor or Datadog or Honey.io or all these different telemetry providers. Something it's important to note is the dashboard stores telemetry in memory. It's not persistent storage of telemetry. We did that because it was intended as a development time feature experience, and it was the easiest thing to do. Sometimes the question will be like, why does the dashboard, is it built this way? Does it do this certain thing? It's often the answer is, this is the fastest way we could provide value and features to users. So the dashboard telemetry is stored in memory. It's basically like just a circular buffer. When you reach a certain limit of telemetry, it will just sort of kick out the oldest structured log, and it will add a newer structured log. And if you want to have a proper store of telemetry, then you should use something more persistent than the dashboard.
Some people expressing their appreciation for the coolness of the dashboard, for being able to operate this way as a container. Someone else asked about wanting to ship their own tool similar to the dashboard, and kind of asking about the packaging of it. Like how do you then distribute a tool like this? I believe we just do it as a container image, correct? Is that you have to get the whole dashboard?
We do it a couple of ways. We do it a couple of ways. We ship it as a container image. That's how ACA, for example, consumes it. That's how people who just want to use a standalone dashboard consume it. We also ship it as an exe, as an executable embedded in a NuGet package. So when you reference the Aspire SDK and you hit F5 and you run the Aspire app, that exe, which is sitting in a NuGet package, is simply run along with the rest of your resources. So if we scroll down to the Aspire dashboard, in this case, because I am running the referencing the dashboard as a project rather than executable, because I'm in the Aspire repo and I want to do development on the Aspire project. Here it's referenced as a project. Typically, the Aspire dashboard will just run as an executable, and the way it's distributed and packaged is in a NuGet package inside the tools directory, and then the local Aspire tooling, it will just run it as an exe resource alongside everything else, and we'll just configure it appropriately so that it starts up and it knows about the app host, and your apps can send telemetry to it and you can browse to it and so on.
I know there's also been a bunch of interesting work happening in .NET 10 in the SDK to make it easier to sort of distribute and run sort of single file tools like this. I know this has been a big emphasis in the model context protocol world, where you want to have a really easy way to build an MCP server that you can then just distribute as like a NuGet package and run. And I think there have been some new verbs added to the SDK to make that more similar to like the NPX experience in the JavaScript world, where you can just like point NPX at an npm package and run some JavaScript. Similar experience coming in .NET 10 for .NET executables. So maybe that could also help as an alternative packaging strategy here too. Cool. Okay. Yeah. What else can it do? What other functionality does the dashboard have?
Yeah, we briefly talked about the telemetry stuff. So there are three pillars of telemetry. It's very important you say 3 pillars, because it really annoys open telemetry experts. They hate when you call it pillars. I think they like calling them signals rather than pillars. But you have structured logs, you have traces, and you have metrics. So structured logs, you can think of it as your typical console logs, but with much more extra metadata. So you get your overall log message, but then like individual pieces inside it are structured. So for example, you can get the fact that this is a post, you can pull out this URL, and then like, you can start doing querying on stuff much easier. And obviously the level is information as well, the timestamp and so on. Traces are, I think, probably the most useful piece of telemetry at development time. So traces are sort of tracking activities and operations that happen in your app. So you can imagine browsing to a website, so get, and then this is saying the root of the website is one operation, and then this is I think this is an HTTP request by HTTP client. So this is doing a GET request to this URL. This is another operation, and then this is now recording the fact that, oh, actually no, this GET here is sending the request from the front-end server, and then this operation is the catalog service receiving the request on this URL. And then the catalog service then talks to the Postgres database to fetch some data. So this is sort of a less raw experience compared to structured logs. Structured logs, you kind of need to spend a bit of time like working out how does this log relate to that log. Traces, it's very easy to see an operation of what's happening in your app here. And if, for example, part of the app wasn't running correctly, you would probably start getting errors. So let's say, for example, I come back here and I stop the Postgres database and the message cache, and I still browse the front-end store. Here it's just saying loading product catalog. So it's failing to get the product catalog because those particular servers are down. And if we come back and look at the traces, we can see that GET request. We can see the front-end call to the catalog service failed because there was some error at some point. And here you can see it's retrying. A trace will look kind of weird until it's completely finished. Okay, so now it's finished. It's sort of timed out after 30 seconds, but you can see we were having trouble talking to the catalog service, and because we've got resiliency set up, it retried 3 times, and we can look here and sort of get more information. We can see it failed, and I don't think this gives the exact failure reason, but we can then click on view logs for this particular trace, and we can see this error occurred connecting to the database catalog DB on the server, and that happened because the server was down. I stopped it. So I think traces is probably the most useful page. I think this is the page people like most when talking about telemetry. And again, there are a whole bunch of options around filtering. You can, like say, I only want to see client IP addresses where it's that, and it will filter it down to only showing traces which contain that particular information, and so on.
Now these visuals that you're showing, like the showing the tree view of the trace hierarchy, and all these property grids, like can you say a little bit about how those got built? Are you using any particular component libraries in order to handle those visualizations, or did you roll all those yourself? Did you custom Blazor components?
So we are using Fluent UI Blazor library. So Fluent UI is a UI library standard created by Microsoft. It's got a certain look and feel. I think it sort of falls into the flat design style of design. And then the Fluent UI Blazor library is sort of Blazor components to make using the Fluent UI bits very easy. So we use Fluent UI basically on every single page. So if we come back to the resources page, we can see all these icons are coming from the Fluent UI icon library. So pretty much every icon you see on this page, like this, all of these ones, that one's custom, that one's custom, but all these other ones are just Fluent UI icons. They're just SVGs that we are pulling out from them. We've got this tab control. So this is a tab control. This is a data grid, a Fluent UI data grid, and there are a bunch of options here. We can do sorting, we can resize stuff, and so on. If we click on an icon, this side panel opens. This is using the Fluent UI splitter library, splitter control. This is a search control, I think. What else have we got? This nav menu is a Fluent UI nav menu, I believe. We've got drop down, Fluent UI select. These buttons are all from Fluent UI. Like they're just standard buttons, but Fluent UI just automatically styles them to follow the Fluent UI style. We've got options here around clearing logs. Like if you're receiving a lot of logs, you can clear them. You can then do an operation, and you can come back and view exactly what you want to see. But this is a Fluent UI menu. This is another Fluent UI menu.
For the charting, like I think on the metrics tab, when you look at like counters and like histogram metrics from your app, I think there's also some charts that show up there. Are those also from Fluent UI, or are those separate?
So this particular control, is using Plotly. So this isn't part of Fluent UI. It isn't being rendered on the server. This is a JavaScript library, Plotly.js, and we're just using JavaScript interop. So the Plotly library is the JavaScript's referenced on the page. We have some JavaScript to set up the grid, and then we send down information to it using JavaScript interop. So all these values, the latest time, we just have some ticks, like a regular tick event, and like every second or so we send down new data. So that's an example of where we sort of using JavaScript interop. Another example is on the resources page. We have this graph table view. We also have a graph view of all the resources. So this is written using D3. So D3 is a JavaScript library for building all kinds of interesting visualizations. I actually think Plotly is using D3 internally, but here it's using a more direct. So this is a force-directed graph. So you can think of each resource as a node. Actually, before I get too technical, let's talk about why this is useful. You can imagine you've got all your resources in your app. Like this is just a flat list. It's kind of difficult to understand the relationships between them. You remember ages ago I showed you can have resources reference other resources. You can say with reference. So here we can see we've got our catalog DB app is talking to our catalog database, which is a database in our Postgres container. If we come back here, we can see catalog DB is sitting under Postgres, but like how are other apps using the catalog DB thing? So we can see we've got our Postgres app here. Actually, I'll not open that. We've got our Postgres app and we've got our catalog database, and we can see that our two catalog services are using it. Then our front end is using the catalog server. So earlier when I stopped the Postgres database, that then obviously stopped the catalog DB, which then caused the catalog service to fail. And then when the front end tries to talk to the catalog service, then the front end is obviously going to fail. But this is built using D3. Again, it's just JavaScript interop. So all this stuff is styled using CSS, and then there's a JavaScript file which is defining most of the logic here, and then we push logic, push the data to it using JavaScript interop. And again, just like you have live updates on that table, if I come along to our Postgres database over here, you'll notice down here, if I click Startup, you can see the statuses of these containers will change eventually to healthy. So if I come over here, they're saying stopping for some reason.
I'm also getting a little. I think I might be getting a little latency on the screen share. I don't know if folks on the share are having trouble seeing the video stay up to date with what James is showing. Let me know.
One second. Maybe that might improve things.
Move the mouse around. Yeah. Okay. Yeah, I can see the resource. You're on the resource list. Yeah. And now you're at the graph. I think it's important to note though that the when you're building with Blazor, you're not limited to the .NET C# ecosystem. You can pull in JavaScript libraries from the JavaScript ecosystem and use them alongside Blazor using the JavaScript interop capabilities that Blazor provides. So it's a nice example, I think, actually, of showing that taking advantage of that functionality. Mm-hmm. We should probably at some point, like they have that little. I think people often call it the frog, the little icon in the upper right hand corner, the goggle guy.
Yeah, AI integration. So we added this in 9.3. The way this works is it just talks using Copilot via your IDE. So you'll only see this icon if you have Copilot set up in VS or VS Code. And even if you have like just the free version of Copilot, it'll still appear. So if you come to traces, for example, if you want to sort of figure out what went wrong, you can either come up here and open this and click investigate, or you can say explain trace. And what this will do is it will take all the OpenTelemetry data that we have and also information about our resources, and we'll send them off to the server. And then the server will do its best to try and figure out what's gone wrong. So like the main goal is like figuring out what's the root cause of why did this request fail. And it's saying here the root cause was database connectivity failures. So it's just saying our catalog service is having trouble talking to the catalog DB, and there's a bunch of errors here, and blah, 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 and sort of like figure out why the Postgres server is not in a running state. So in this case, it sort of accurately identified the fact that the problem is the Postgres resource isn't in a running and healthy state.
So you get basically an AI agent helping you look at your telemetry and logs to diagnose issues with your application during development. That's pretty cool.
Yeah, so you can do it in a whole bunch of places. You can sort of ask, like, summarize the resources I have, and it will sort of say, I've even seen this sort of like guess, like, what is your app? What kind of app are you building? Not that that's terribly useful, but here it's saying your app is mostly operational, but for some reason your Postgres database is unhealthy. You should investigate why this isn't a stopping reason. I think probably I'd need to restart the entire app. So I'll just do that now, and we'll see if things get into a bit more of a healthy state.
And under the covers, that AI integration, is that built on top of the Microsoft Extensions AI libraries to be able to talk to the models?
Yeah, basically. We use the standard library. It worked pretty well. We use a bunch of tools. We set up functions to fetch data based on what you need to have answered. So for example, if you're having trouble with a trace, sometimes the app will preemptively just decide, okay, let's get all the resources, let's get all the logs for that particular trace. So for example, if we have a front-end request here, you have the ability to view logs for this particular trace. So you can click view logs up here, and this will automatically filter down the logs you have for this particular trace here. You can see a filter and view this information. You could imagine AI, you ask it to explain this trace. If it sees a problem, quite often it will then decide, I'm going to go off and then also fetch the logs, and I'll investigate further.
Very cool. Yeah, that's great. Okay, I know we're getting it to time here on the stand up today, but I wanted to hear from you, like, given your experience working with Blazor on the dotnet Aspire dashboard, what would you like to see improved? Like, what doesn't work so well? What things would you think could use a little bit more attention?
One thing I've struggled with is the scoped CSS files.
Mm.
Like if we pull up this, for example, so this is CSS that is only supposed to apply to a resources page. So we've got a resources page, we look at the resources CSS. I always have trouble with like figuring out where that deep should be. Like deep is like this selector to tell you to say, to be honest, I just have trouble in general with this
What does
area.
that mean?
So,
Okay.
yeah, what does that mean? So that's one of the things I have
Counterintuitive?
trouble with. Like maybe you could explain it to me sometime, or maybe it's a matter of improving the docs. The other thing is we use a lot of grid virtualization. One thing you would have seen when I've been showing Aspire is data is always updated live. That's sort of one of the philosophies I've had when building Aspire, is it's always live updating, and also there's no paging. So we use a lot of continuous lists. So this is only got 85 results in it at the moment, but you could imagine what happens if you have 10,000. You don't want to render 10,000 items to this grid. But we are always scrolling to the bottom, so we sort of act like a console. As new data comes in, we automatically scroll to the bottom to view it if you're already at the bottom. And I've noticed that's a bit inefficient with the way the virtual grid works, because we need to sort of add that behavior ourselves. We add some JavaScript interop to detect when the scroll bar changes. So new data arrives, the scroll bar position changes because there's new data, the scroll bar isn't technically at the bottom, and then we tell the scroll bar to scroll down, which then does another query back, and it's not quite as efficient as I'd like. Yeah, so those are the two things.
A virtualized list over some data set that's kind of dynamic. That's changing under the model. You need to be able to react to that more efficiently.
I think it's to the virtualize control, add a mode where you say that rather than you're at the top and you expect new data to arrive and it is added to the bottom, your mode is you're automatically at the bottom, and as new data arrives, you just stay fixed to the bottom.
So they keep up with it, like keep following
Yeah,
the
yeah,
update.
exactly.
Yeah, okay, yeah, I get that.
And
just
another one.
Oh.
Another feature related to grids virtualize is supporting dynamic height. Right now, it assumes that the height is fixed. On the console logs page, we have wrapping enabled, which makes things not have a consistent height. And the scrolling means, and non-consistent height means scrolling can sometimes mess up on this page. I think we're going to have to disable wrapping to fix this.
Yeah.
But being able to support dynamic heights would be useful. I do know it's possible in some way because I have seen other controls and frameworks support it, but right now Blazor doesn't.
It is. I know we have that's certainly an item on our backlog that people have asked for. I know it's trickier than the fixed height variation, which is why we haven't done it yet. But yeah, we hear you. You're not alone in that particular ask. For people that were curious about that deep the deep pseudo selector in scope CSS, that should tell that style to apply to all the children of that particular component. Like without it, it'll just apply to that component and that component only. But if you want it to drill down into child components as well, that's what that selector is supposed to do. I believe there are some subtle nuances to it though, like whether or not you have a wrapper element around that component and so forth, that can make it a little tricky to reason about. So we could probably make that simpler. Well, great. That was fantastic. I know we're at time. There were a couple of other questions. I'll throw one other question on the board that someone asked about. Can you handle SignalR connections in the Aspire dashboard and use service discovery with them in Aspire? Do you know the?
I don't know. I think you can certainly get a reference to like the host and the fact that let's say, for example, your front end is talking to your catalog service, you would be able to get the host name, and then you could inject that yourself. I don't know whether the SignalR client has service discovery built in. I'm not sure about that.
I mean, there's the SignalR client, like if you're doing it from JavaScript, where you'd have to flow the endpoint into the browser. With server-side Blazor like this, where Blazor server-style app, where you're using the .NET SignalR client, I would think that the normal, like in Aspire, the service discovery is kind of like a conventional URI, right? That kind of gets replaced with the actual address of the thing that you want to talk to, and I would think that should just work when you're trying to talk.
Yeah, you use the HTTP client factory, and then you give it this interesting URL that isn't a real URL, and then service discovery will replace it for you at runtime. So I think you could get an instance of an HTTP client and then use that HTTP client to create a SignalR client. I don't know if you can do that or not with SignalR, but at the very least, if the way this technically works is service discovery is really just environment variables injected into your app. So for example, the catalog service is talking to the catalog DB. The environment variable was just passed in using this convention, and then you can always just access it directly yourself from iConfiguration, given the environment variable name, and then set things up yourself.
And then when you see the SignalR traffic at runtime, I know we've done a bunch of work actually I think it's in .NET 10 to improve how SignalR traces show up in the tracing view, where instead of it appearing as this sort of one giant long request, because SignalR connections are usually long-lived, you'll actually see it sort of broken up into the individual hub method invocations, so it's much easier to parse and reason through. Similar improvements for Blazor server apps in 10. We've done a lot of work to clean up how the traces show up in things like the Aspire dashboard. All right, I know we're over time. James, that was fantastic. Thank you so much for sharing with us the awesome work that you guys are doing on the .NET Aspire team with the dashboard. It's really cool to see a real world Blazor project in action. Folks on the
Not a
stream, if you
problem.
want to follow along, you can of course go to the Aspire repo and check out the code there and see the improvements that are being made. Even try your hands at contributing some improvements to the dashboard as well. And yeah. James, thank you for coming on the show.
Whoa. My pleasure. That was great.
Thanks, everyone. Have a great rest of your day and happy Blazoring.